Workshop 2. Measuring the color of pre-dyed and dyed cotton yarns. Now we move on to the color measurement of pre-dyed and dyed cotton yarns. Consistent, accurate color assessment is essential to ensuring that textile products meet quality expectations. Whether you're evaluating yarns before dyeing or checking post-dye results, precise color data helps reduce variability, support uniformity, and maintain control throughout the production process. Why measure pre-dyed yarns? Before dyeing takes place, it's important to assess the natural color of the yarn. This helps colorists adjust for batch variations and evaluate the yarn's cleanliness and whiteness. When you reduce variation at this early stage, you set the foundation for better dye uptake and consistent final color. Demonstration. We start by securing the yarn with a skein holder. This tool helps maintain uniform tension and opacity during measurement. When yarn layers are inconsistent in thickness or density, measurements can vary. The skein holder helps eliminate that problem and ensures accuracy. The challenges of measuring yarn on cards or looms. Some mills choose to measure yarn by wrapping it onto cards or looms. While this can be convenient, it often introduces inconsistencies. Background color can influence readings, and differences in fiber tension, humidity, or dye bath parameters can create additional variations. Using standardized tools like skein holders gives more reliable, repeatable results across batches and environments. Measuring dyed yarns for quality. For dyed yarns, color consistency is everything. Small changes in dyeing variables can lead to visible differences between batches. To monitor this, operators use color scales and indices to track. Overall color accuracy using delta E star. Visual differences using grayscale ratings. Key metrics like whiteness index and metamerism index. Demonstration. We measure using the industry's #1 color spectrophotometers for dyed yarn, HunterLab's Agira L2. This instrument can operate independently or be connected to EasyMatch QC software for deeper analysis. Agira L2 helps you evaluate color precisely and maintain high standards in post-dye quality control. Applying the Kubelka-Munk algorithm. Behind every accurate dyeing process is a bit of science. The Kubelka-Munk theory relates a yarn's color to its absorption and scattering properties, depending on dye concentration. Understanding this relationship allows mills to fine-tune their dye formulations and control shade outcomes more effectively. Practical tips for reliable color measurements. To reduce variation in color measurement. Mount yarn samples with even tension and avoid twists. Ensure each layer is consistent and homogeneous. Use opacity correction when needed. Average multiple readings to eliminate outliers. Common indices include CIELAB, CIELCH, and RDAB color scales. Whiteness index for pre-dyed yarns. Metamerism index for dyed yarns. Delta E star and grayscale for evaluating color differences. These practices help operators standardize their process and maintain visual consistency. Process variables that affect yarn color. Yarn color is influenced by several variables. For example, L star values, representing lightness, change with dye concentration. Higher concentrations lower L star values, creating darker colors. Lower concentrations increase L star values, resulting in lighter shades. This applies across all dye types and colors. Other process factors include fabric loading weight, liquor ratio, running rate, cycle time, dosing rate, temperature, adsorption rate. Cotton yarn typically shows an 80% dye pickup rate. Monitoring these parameters helps mills keep results consistent and reduce costly color mismatches. Recap and takeaway. Color measurement is more than a technical process. It is a powerful tool for ensuring quality and consistency in textile production. By mastering these techniques, your mill can reduce variability, improve efficiency, and meet customer expectations every time.